Hello, welcome to your video on linear inequalities. I'm going to take a step back for just a second on linear systems of equations, and we're going to eventually transition to systems of linear inequalities. But before we can do systems of inequalities, we have to know what linear inequalities are. So that's what you're going to learn today in this video. Let's get started. Vocabulary. A linear inequality is formed by replacing the equal sign with a linear in a linear equation with an inequality symbol. The example I have for you would be, for example, y is greater than x minus 3. You've seen y equals x minus 3. That would be the equation. The inequality just replaces the equal sign. A solution is an ordered pair, nothing abnormal there, that makes the inequality true. Alright, let's start with identifying solutions to inequalities. Here we have an example of y is greater than x minus 3. Then we're going to see if the coordinate 1, 2 and negative 3, 7 are solutions. So here we're going to, just a quick reminder that this is your x coordinate and this is your y. You're going to insert them in those spots. So 2 is greater than 1 minus 3. 2 is greater than negative 2. That is a true statement. So the answer is then yes. Second one. 7 is greater than negative 3 minus 3. 7 is greater than negative 6. Oops, should be negative 7 in both of those instances. So negative 7 is greater than negative 6. That is not true. So the answer would be no, it is not a solution. Alright, graphing. When we are graphing inequalities, linear inequalities, they get treated just like equations, except for there's not an equal sign, and the lines can look just a little bit different. And what I mean by that is, when you're drawing an inequality, here's two examples for you. In the left one here, you notice the greater than sign. The greater than sign for the variable, because it's just greater than, you have a dashed line. And then where is the solution true? That would be the shaded in part. So if you were to actually solve, you would shade in the part that is a solution to the equation. Here we have a less than or equal to symbol. And that you see is a solid line, and then you shade where the solutions would be found, because there will be more than just one solution. There will be many. So the example we're going to do first is y is greater than x minus 2. So the first thing you're going to do is make what's called the boundary line. That's just the line that you're using, because it is a greater than sign and there is not a bar underneath. You're just going to use a simple dotted line, and you're going to use the y equals x minus 2 as your boundary. So you're just kind of replacing that equal sign in there instead of the inequality. So we start at negative 2, then we go up 1 over 1, and so on. So these, and then you're actually going to make a dotted line, what we talked about. This is going to be a dotted boundary line, and you're just using those points. Make sure you fully extend using arrows. And then you're going to pick a coordinate on one side or the other. It doesn't matter which one you pick. Obviously, some are easier than others. For example, 0, 0 is a great one to use. Very simple math. So that point right there, 0, 0, minus 2, so 0 is less than negative, or greater than, negative 2. That is a true statement, so it is a solution, which means this would all get shaded in. You color that in, so anything up to the boundary line on that side will be a solution. Right, now we're going to talk about two special cases. The first one is x is greater than -1. You've seen x equals -1, so you're going to use that as the boundary line. This x, because it says x equals, that means it never crosses the y-axis at -1. So here's my boundary line. I'm doing a dotted one because there's not an equal to sign. And then I pick whichever. I'm going to pick 0, 0 again. So 0 is greater than -1. And obviously that is a true statement. So we are going to shade in that area. And that is the solution to our inequality, anything in the shaded region. Last one we have is y is greater than 2. And we are going to use the y equals 2 boundary line. Because this is a greater than or equal to symbol, we will have a solid line. I'm going to use the point 0, 0 again, but you can use whatever. 0 is greater than or equal to 2. That is not true. So you will shade on the side that does not include 0, 0. So I'm going to shade up top here. Last thing we're going to do is write an equation or inequality. You're going to treat it just like an equation though. So you're going to find your y-intercept and your slope. Y-intercept is 2. And then your slope is up 2 over 1, so your slope is 2x plus 2. And then we have y, and we know that there's a bar underneath because of the solid line. And then we have to figure out which way, if it's greater than or less than. Because the line is, the color is shading below, I know that the symbol is going to be a less than sign. But I can check it just to be certain. If I put in 0 for each of these values, okay, I have 2 is greater than or equal to 0. That's true, so I know that I did shade the part properly. I have the answer correct. All right, your turn. Please graph the two that are given and then write in it the inequality for the third. Then check it back in when you're done. All right, we will go over what the graphs should look like in class, but then the answer to number 3 is written there for you. That is the end of your video. Thank you for watching. I look forward to working with this in class with you. Have a great day.